class. You are welcome to JoeNewton online physics and maths. Here we have physics question on the board, and of course, this has to do with equilibrium of forces by the diagram, that is non-parallel coplanar forces. Good. Now, let's look at the diagram. We are given a diagram like this. We have two cords holding a body of mass 20 kg suspended, fixed on this rigid body. So they are now in equilibrium. Then we are asked to calculate the tension T1 and T2 on the cords with which this body is in equilibrium. Good. Then we are given the approximate value of acceleration due to gravity in bracket. Remember, sometimes it might not be given. You have to solve it. Okay, so what are we going to do here? We remember the principle of equilibrium. Yes. So when you have non-parallel coplanar forces, in a state of equilibrium, the three forces can now be resolved with the three sides of a triangle taken in order as far as the three forces intersect at a point like this. So the first thing we are going to do is that this tension is a force. The tension on the cord means forces on the cord. That force per unit mass, that is tension on a cord, force per unit mass. Of course, we are asked to neglect the mass of the cord in this problem solution or in this question. Then this mass, this body, the mass is given in kilogram. So the first thing we are going to do is to convert this mass to Newton. Then we resolve these forces into three sides of a triangle taken in order, bearing in mind to get right-angled triangle. Okay? So for this, we have that for this one, the mass is force is equal to weight, which is equal to mg, mass times acceleration due to gravity. Therefore, we will now have this 20 kg will now become 20 times 10, which is acceleration due to gravity. So giving us 200 Newton. So this becomes 200 Newton. That is the weight or the force due to the mass of this body or the weight of this body in Newton. Having done this, we now come to resolve this into three sides of a triangle according to the rule or the principle taken in order. Okay, this is the weight of the body acting downward. This is the tension, dragging this one. This is the tension here. Okay, so when we resolve this, let me use broken line here. When we resolve this, we'll have this. Then we'll have this now. Then take this. You see what I'm doing? So we have this, resolving it vertically and horizontally. So when we have this now, remember this angle here is equal to the angle here because alternate angles are equal. The angle here is equal to the angle here because alternate angles are equal. So here will also be 30 degrees. Good. And do not forget that this place, is also corresponding to this place, equal to this place. So this one is equal to this place, which means I have here this force here, I have this force here as well, 200 Newton here. Then this is my tension. This tension is also equal to this place. This place is equal to this place, while this place is equal to this place. Very simple. You see how I have resolved this to get a right-angled triangle in order with the three sides of the triangle. So what we have here now, we have this right-angled triangle from our resolution. This is what we have. We have here to be 200 Newton. We have here to be angle 30 degrees. Then we have here as our T2. Then we have here as our T1. Here is T1. That's good. So this is what we have. This is what we have. Resolution by vector. So we have this. So vectorially, we have resolved these forces in equilibrium into three sides of a what? A triangle. But these are three forces, the two tensions and the weight of the body. Three forces intersecting at a point, and they are non-coplanar. They are non-coplanar forces because they are not on the same plane. Good. Okay. Now we come to the solution. The first one, I question. We are asked to find the tensions that are T1 and T2. So for T1, we now remember the trigonometric function, the trigonometric ratios. The trigonometric ratios will help us now in solving it because this is a right angle triangle as we have resolved. So in the trigonometric ratio, we now remember our SOHCAHTOA. Remember our SOHCAHTOA. Recall our SOHCAHTOA that sine is opposed to our hypotenuse, cosine is adjacent to our hypotenuse, and tangent is opposite to our adjacent. So we are interested in T1. So we are going to look at a ratio that will involve the T1, the angle, and the available given side. Do not take a ratio that will involve two unknown values. You cannot, to be complicated, you cannot solve it. So taking it now, so you don't take this arbitrarily anyhow. You have to check the condition, whether it meets what you are looking for. We're using available parameter or information given. So this is sine 30. Let's check sine first. Sine 30 is opposite of a hypotenuse. So it will work out. So we're going to use sine 30 because it involves the opposite. Opposite means the side facing the angle. Opposite. That is face to face. That is opposite. Then adjacent is the other line that is not facing the angle in question. Hypotenuse is the longest side of that right angle triangle facing right angle. You should know this. So hypotenuse is always constant, but the opposite and the adjacent depends on where the angle is positioned, the angle you are talking about. Okay? So in our case here, we are going to use sine because sine 30 is opposite over hypotenuse. So it involves the T1 we are looking for and the available side. Okay, so we now say sine 30 degrees is equal to 200 over T1 opposed to our hypotenuse. Then to get this over 1, we cross multiply. Therefore, we have that T1 sine 30 degrees will be equal to 200. So to find T1, we divide both sides by the coefficient of what? T1, which is sine 30. So T1 is equal to 200 over sine 30 degrees. Now, sine 30 degrees, remember that sine 30 degrees, we remember that sine 30 degrees is equal to 1 over 2 or 0.5. 1 over 2 or 0.5. That is sine 30 degrees in our trigonometric ratio functions. Okay, so we substitute it here. Let's use 1 over 2. So that will give us that T1 is equal to 200 divided by 1 over 2. Mathematically, it means 200 times, you change this. When you have division here, you put multiplication and invert the fraction times 2 over 1, which is equal to 400 Newton. Remember, the unit of force is Newton. That tension is force on that cord. So it's 400 Newton is our T1. Good. Let's work our T2 here. Then for T2, we now go for T2. T2, we check cosine. Cos 30 is adjacent over hypotenuse. Cos 30 is adjacent over hypotenuse. Tangent 30 is opposite over adjacent. So you can see that now we have found this place. We can either use cos or tangent to find what? The other side, which is what? T2. But let's use cos. So we use cos 30 degrees is equal to, now, what is the adjacent? The adjacent is the T2. Yeah, the other side that is not facing the angle. Remember, if the angle is here, here it becomes the opposite. So be careful, but the angle is here. Here is the adjacent. Okay, T2. What is the hypotenuse? The hypotenuse is T1. So equals to T2 over T1. But remember our T1 now, we have found our T1 to be 400. Therefore, we now have that cos 30 degrees is equal to T2 over 400. Because we have obtained our this to be what? 400 Newton. That's our answer here for T1. So for you to get T2, you cross multiply. Therefore, when you cross multiply, you have that T2, 1 times T2, T2 will be equal to 400 times cos 30 degrees. Good. Now, what is cos 30? Cos 30 degrees is equal to root 3 over 2, or 0.8660. So root 3 over 2. In our trigonometry ratio functions, we have that cos 30 is root 3 over 2. Is a complementary to sine 30. Okay, so we have this. So our T2 will now become 400 times root 3 over 2, which will be equal to 2 divide itself 1. 2 divide 400 will give us 200. So we have 200 root 3. So that's our answer. So our answer now is that T2, our T2 is equal to 200 root 3. Simple and short. You can leave it like that. Remember the unit. Put the unit Newton, 200 root 3 Newton. Then if you wish to go into a decimal value, you can multiply by this. Use 200 to multiply this. You get the answer in decimal values. Thank you for paying attention to this class. For more of this on physics and mathematics for tutorial, private tutorial lessons, you can chat me on my WhatsApp number here or drop message in my inbox. Then keep following me on this Facebook page, and do not forget to subscribe to my YouTube channel at JoeNewton Online Physics and Maths to enjoy more of physics and mathematics, and share this video so that others will also enjoy with us. Thank you and God bless you. Bye-bye.